Quasars. And it's a short form for quasi-stellar radio sources. And this name is just a byproduct of the first observations of quasars, because all they look like were these kind of point-like sources of electromagnetic radiation, mainly in the radio part of the spectrum. So that's why we called them quasi-stellar radio sources. Now it turns out that they are neither stars or even quasi-stellar, and they're actually not even, their main energy isn't even being released in the radio frequency, in the radio band of the electromagnetic spectrum. They're far more energetic than that. What they really are the active nucleuses of galaxies. So let's think about that a little bit. So if we have a supermassive black hole at the center of a galaxy, so let me draw that right over here. So that's our supermassive black hole. Maybe that's the surface of the event horizon of the supermassive black hole. The actual mass of the black hole is in the center of that event horizon. If there is material that's passing by this black hole, it's going to get attracted to it, and it's going to form an accretion disk around it. This material is going to start rotating around this black hole, and some of it, if it doesn't have enough velocity, is going to actually fall into the black hole. So you have all of this material going around the black hole, and some of it, if it doesn't have enough angular velocity, not enough to orbit around the black hole, it's actually going to fall in. Now, let me label this. This is the accretion disk. Accretion disk. So as things are getting faster and faster as they fall closer and closer to this black hole and bumping into each other more and more, that gravitational potential energy from things falling into it is being turned into actual energy, actual temperature. And so what you have is things start to get really unbelievably hot near the surface. They get hotter and hotter as they fall closer and closer to that event horizon. And so near the event horizon itself, things are so intense that they're actually releasing high frequency electromagnetic radiation, mainly in the X-ray part of the spectrum. Now, I want to be very clear. So there's two things here. One is when you learn about quasars, or when I first was exposed to quasars in like a NOVA special, they make you think that the radiation is somehow being released by the black hole itself. And I want to be, and I would scratch my head because I was just told that nothing can escape the event horizon of a black hole, including electromagnetic radiation. So how could that be being emitted by the black hole? And the answer is it's not being emitted by the black hole. It's being emitted by the matter in the accretion disk that hasn't quite gotten to the event horizon yet. Once it's inside of the event horizon, it can no longer, any electromagnetic radiation that it might emit will not be able to escape the black hole anymore, will not be able to escape the actual event horizon. So all of this is from the accretion disk around the supermassive black hole. And the other question that used to pop in my mind is, why does it come out at these kind of perpendicular, orthogonal to the plane of the actual accretion disk? And they're just, at least my logic tells me, well, things aren't going to pop out they're not going to pop out along the direction of the accretion disk, because then they're going to be absorbed by other things. In fact, that's what's going to cause other things to get heated up closer to the actual event horizon. So any energy that's going out in that direction is just going to be absorbed and make other things hotter. And only when you go roughly perpendicular to the plane of the accretion disk is that energy allowed to kind of go and transmit freely into space. Now I want to be very clear. Quasars are these are the most luminous things that we know of in the universe. So most luminous things that we know of in the universe. The brightest, or actually many quasars are on the order of 1 trillion suns in luminosity, so they can be brighter than an entire galaxy. And that's just coming from material around a fairly small region of space, much smaller, much smaller than an actual galaxy. It's the very center. It's kind of just the galactic core. Now, another interesting thing about quasars, and this kind of gives credence to this notion of a constantly changing universe, and even to some degree the Big Bang itself, is you have these supermassive black holes that may be formed shortly after the Big Bang. Now you can